Good day, everyone. Today, we are diving into the practical power of influence line diagrams, or ILDs. Instead of analyzing a structure under a fixed load, ILDs let us track exactly how shear force and bending moment change at a specific section as a live load moves across the span. Today, we are analyzing a 20-meter simply supported beam under a moving live load. Our goal is to determine the absolute worst-case structural reactions at a specific section, point D, located 5 meters from the left support. The moving load is an 8-meter-long, uniformly distributed load, with an intensity of 10 kilonewtons per meter. Before calculating the maximum load effects, we must establish our baseline influence lines. For shear force at point D, our positive peak equals 0.75, and our negative peak is 0.25. For the bending moment at D, the peak directly under the section is calculated using A times B over L, yielding a maximum peak ordinate of 3.75 meters. To find the absolute maximum bending moment, the section must divide our moving load in the same ratio as it divides the total span. This creates a 1:3 ratio, meaning we place 2 meters of our load to the left of point D and 6 meters to the right. By calculated geometry, the ordinates under both ends of the load drop to 2.25. Multiplying the load intensity of 10 by the shaded trapezoidal area yields a maximum bending moment of 240 kilonewton meters. Now let's maximize the positive shear force at section D. To do this, we place the trailing edge or tail of our 8-meter load precisely at section D and extend it out to the right. This positions the load entirely within the positive zone of our influence diagram. The ordinate value directly under the front of the load scales down to 0.35. Calculating the trapezoidal area under the load and multiplying by our intensity gives us a maximum positive shear force of 44 kilonewtons. Finally, to calculate the maximum negative shear force, we place the leading edge, or head, of the load directly at section D, extending it backward toward the left support. Because our beam segment is only 5 meters long, the 8-meter load completely covers the negative region, while the extra 3 meters simply spill harmlessly past the left support. Multiplying our 10 kilonewton per meter load by the full area of the negative triangle yields a maximum negative shear force of 6.25 kilonewtons. Thank you for watching this video on structural analysis.